You know that bottle of soda you accidentally left in the freezer for a little too long? It comes out all slushy and icy. Well, it turns out that inside that simple bottle, some really, really weird physics is about to go down. So let's unpack the science that's literally hiding in plain sight. So here are the two big mysteries we're going to solve. First, why is it that the second you crack that cap, the whole thing erupts in a crazy fizz volcano? And then, even weirder, why does the bottle start to slowly crush itself as the ice inside melts? It feels completely backward, right? But the answers, they're pretty fascinating. Okay, before we can get to the bottom of these puzzles, we need to get on the same page about what we're actually dealing with. Let's set the stage for a little physics experiment here. So think about what we've got. First, it's a carbonated drink, which means it's full of carbon dioxide gas that's been forced into the liquid under high pressure. Second, this thing was frozen solid. We're talking a frigid minus 19 degrees Celsius. And third, right now it's starting to thaw, so it's the slushy mix of solid ice and liquid soda. And that combination, well, that's the perfect recipe for what happens next. All right, let's tackle mystery number one, that big dramatic eruption. What in the world is going on the exact moment you twist that cap? I mean, just look at the difference. When the cap's on, everything is under super high pressure, and the soda is just sitting there, totally calm. But the second you open it, that pressure just vanishes, and bam, you get this instant, violent mess of fizz. It's like flipping a switch from calm to complete chaos. But here's the thing. That chaos isn't random, not at all. It's physics. And to really get why that surge happens, we need to look at a basic rule that controls how gases and liquids behave. Okay, so the main idea here is something called Henry's law. Now, it sounds all complicated and science-y, but the concept is actually super simple. High pressure forces gas to stay dissolved inside a liquid. Think of it like a bouncer at a club, keeping a huge crowd packed inside. The moment you open the door, or in our case, the bottle cap, the pressure drops and all that gas has to get out. It's this perfect lightning-fast chain reaction. You twist the cap, the pressure disappears, and all that CO2 that was dissolved in the soda suddenly says, I gotta get out of here. It forms into bubbles like crazy and rushes for the exit. And it drags a whole bunch of liquid soda right along with it. And that is your eruption. But why is it so much more violent with a slushy soda? Well, the secret is something called nucleation sites. Bubbles need a little rough spot to get started, to form on. And that big chunk of ice in the bottle, it is the perfect launch pad. It's covered in tons of tiny little imperfections that are ideal for CO2 bubbles to form all at once. So it looks like the ice itself is fizzing, but really, it's just setting the stage for the great escape of all that gas. Okay, so we've solved the eruption. But what about that second, much quieter mystery? You know, you put the cap back on, and as that ice starts to melt, the bottle just crumples. What is going on there? So, the key thing to notice is that the bottle isn't just collapsing on its own. It's actually being pushed inward. That means the pressure on the outside of the bottle is stronger than the pressure on the inside. The real puzzle is, why does that pressure difference suddenly show up while the ice is melting? Believe it or not, the answer lies in one of the absolute strangest and most important properties of water. It's a little secret that explains a ton about our world, from why icebergs float to, well, why this soda bottle is collapsing. So here it is, water's weirdest secret. Pretty much every other substance on Earth gets denser when it freezes. It shrinks. But water is a total rebel. Ice is actually less dense than liquid water. And that, of course, is why it floats. It also means that when water freezes, it expands. And we're not talking about a tiny little bit. Ice takes up about 8.7% more space than the same amount of liquid water. So, if freezing water makes it expand, what do you think happens when that ice melts? You got it. It contracts. It shrinks. As the ice in that sealed bottle melts back into liquid, the total volume of stuff inside actually gets smaller. This creates a partial vacuum, which means the pressure inside the bottle drops. And now the normal air pressure on the outside is way stronger, and it simply squeezes the flexible plastic bottle inward. Mystery solved. And look, this isn't just a cool party trick for soda bottles. This one weird property of water is why massive icebergs float instead of sinking to the ocean floor. It's why a water pipe can burst in the winter. That expanding ice is incredibly powerful. It's even why lakes freeze from the top down, which protects all the life underneath. It's a fundamental feature of our entire planet. So let's wrap this all up. Let's put the two pieces of our slushy soda puzzle together. So, it really all boils down to two big science ideas. That crazy eruption when you open the cap, that's all about pressure and gas. That's Henry's law doing its thing, with the ice acting as the perfect launch pad for the CO2. And the mysterious, self-crushing bottle, that is the beautiful, weird anomaly of water, where melting ice actually shrinks, creating a vacuum that lets the air around us do all the crushing. It just goes to show you there's this incredibly complex and fascinating physics happening all around us, all the time, in the most ordinary things. It really makes you wonder, doesn't it? What other everyday physics are we all missing?